Hi Year 9, welcome to your recorded lesson for this week. So whenever it says you've got a live lesson this week, this is what it means. Only really it makes sense for us to do it as a first lesson of the week because we're starting a new topic, but this takes the place of whatever slot you've got as a live or pre-recorded lesson this week. So next 2 weeks, our new topic is area and perimeter. We're not going to spend too long on the basics as you're higher set. You will have done a lot of these things before. We're going to look at some of the stuff that you'll really need to be able to do kind of to get our 7s, 8s and 9s at GCSE. Make sure you've got your calculators already, guys, because a lot of the harder area work you will need a calculator for. But we're going to start with a problem solving question using some fairly basic stuff to do with areas of rectangles, but I just want to see how well we do at answering it. So this is taken from one of the higher papers. We've got a floor plan of a rectangular room, some information about how much it's going to cost to tile the room. So if you could have a quick read through that, spend about 5 minutes trying to work out the total cost of the tiles and fitting them, please. Okay, you can use calculators if you want to. And come back in a few minutes and check your answer. Okay, so this is a method I did. If you've done a different method but got the same final answer, then you will have got all the marks. Okay, but this is a method I used. I think this is probably the method most of you will have used. First thing I did was I worked out that on the 3 meter side, I'd need 6 of these 50 centimeter tiles, and across the 4.5 meter side at the top, I'd need 9 of them. So overall, I'd need 6 times 9, which is 54 tiles. Okay, so that would have got you your first mark. I then worked out because tiles are sold in packs of 10, I'm going to need 6 packs of tiles. That's going to get you up to 2 marks if you've got 6 packs of tiles. Cost of a pack is £120. I then worked out the area of a room, which is 13.5 meters squared. Worked out the cost of fitting, and if we look at it, it's £7.50 to fit it, but you need to round up any fractions of a square meter. So actually you need to pay for 14 meters. So the cost of fitting it is £7.50 times 14, which is 105. So then the total cost, 120 plus 105, gives us 225. Okay, so that's a 5 marker, I think it was. So a mark for tiles, a mark for packs of tiles, a mark for the area of a room, a mark for the cost of fitting, and your answer mark for the total of 225. Okay, so that's probably all you'll have gas to do on the higher paper to do things like areas of rectangles, triangles, that sort of thing. It'll be set in a problem solving context. We're going to jump straight on some of the slightly harder stuff then. Hopefully this is something you already know about, but just a quick recap because people always forget this one. A trapezium, a quadrilateral which has 2 parallel sides, your method of working out the area of it is to add together a parallel side, so a plus b, multiply by the height and halve it. So if we look at a quick example, we've got parallel sides 6 and 10, add them together, multiply by the height, so 16 times 12 is 192, and halve it to get the area. So the area is 96 centimeters squared. So just really quickly then, guys, use your calculators, work out the areas of those 4 trapezia. Okay, not trying to be patronizing, but it's something a lot of people forget. Okay, so take 5 minutes, work out the areas, come back and check your answers. Okay, so that's what you should have got, guys. Number 4, sloping side isn't used for anything, so it's only really less tricky. Okay, you'd use it for perimeter, but not for area. Okay, so moving on to sort of a slightly harder stuff. Circles, something you should have seen before. We've got a circle with a radius of 6 centimeters, which means diameter is 12 centimeters. Circumferences and areas all to do with this number pi. It's what's called an irrational number, a decimal that goes on forever without repeating itself. So circumference pi times diameter, area pi times radius squared. Okay, you don't get given these formulae, so you need to make sure you don't mix them up. So if you want to really quickly work out circumference and area of a circle, please. If you could do it as a decimal and in terms of pi. Okay, circumference, pi times diameter, pi times 12, 37.7 or 12 pi. Area, pi times 6 squared, 113.1 centimeters squared, or 36 pi in terms of pi. Okay, so if you could find the area and the circumference of these circles, please, guys. We'll come back and check our answers in a second. Okay, so for the first three, it's what you should have got. Made a little mistake here. I should say centimeters, not centimeters squared for the circumference of the second one. But that's what you should have got. Okay, so again, on the higher paper, they like to make these questions a bit more complicated. It's not just sticking numbers into a calculator. So this was from one of the higher papers. It was another 5 marker. We've got a semicircle inside a rectangle. What you need to do is calculate the perimeter of this shaded region up here. Okay, so pause the video, spend a few minutes, try and work it out, give your answer correct to 3 significant figures. Okay, so what you should have done, I would have started off by writing that the width, this side here, is 60 meters. That would have been enough to get you 1 mark. I've then worked out the circumference of a full circle, which is 120 pi. And the curved bit is a quarter of this, which is 30 pi. 120 pi divided by 4 is 30 pi. You might have done that as a decimal, so 90 something, 93 and a bit, doesn't matter. Okay, so if you've got a width of 60 and a curved bit, which is a quarter of a circumference, then that would have got you first 3 marks. I've then added together the width and then the distance to B, which are both 60 to 30 pi, rounded it correctly, and I should get 214 to 3 significant figures. Okay, the final mark is for the rounding. So if you got 214 point something, you only got 4 of 5 marks. If you had no idea what to do and just made up a number and then rounded it, you still would have picked up 1 mark. Okay, so that's what we should have got for that question. Right, last thing we're going to run through then, and this is a formula for how you work out the area of a triangle if we don't know the height. So obviously if you know the height, it's base times height divided by 2. But if you don't know the height of a triangle, but you've got 2 of the 3 sides and 1 of the angles between the 2 sides, you can use this formula. So it's a half of AB sine C. A and B are 2 of the sides, and big C is the angle in between sides A and B. Okay, and there's a proof which actually isn't particularly difficult, but you don't need to know the proof. But there's a proof on this slide here of where that formula comes from. So you can see we've got A and B here, C is in between them. So if you want to pause it and have a look at that proof, you can do. But just a really quick example of how to do it then, you've got a triangle with sides 6 and 7, so A and B are 6 and 7. Angle C is 35, so it's a half times 6 times 7 times sine 35. Plug it into your calculator just like that. You get an area of 12 or 12.0 centimeters squared. Okay, and it's always a half because it comes from the formula half base times height. Okay, so 3 triangles on the board, guys. Pause the video and see if you can work out the answers to them to 1 decimal place, please. Right, so we've got 30.3, 76.2, and 184.9 centimeters squared. Okay, so we've run through a bit of problem solving, a bit of a recap of trapezium, areas of trapezium, a bit of a recap of circles, and also how we can work out the area of a triangle if you don't know the height. Okay, so make sure you've written down any relevant formulae, done the examples in the video, then have a go at some of the written and online work attached to this post on the classroom. Okay, thank you guys.